Now, using technology is useful for handling large sets of data. Really, it's the only reasonable way to do it. However, if you have smaller sets of data, such as near problem sets, you could also um, create a frequency distribution followed by histogram manually. So that's what I'm going to do as an example now, how to um, complete exercise 1 on paper. So here we go. So exercise 1, here's the data. The duration of 40 phone calls in minutes and the technical support location is given below. And I'm just going to make a tally of the various results. So the first data piece is 12. So 12 falls into there, into that box, because if something is right on the border, you put it in the next um, um, bin up. And that's the convention. And then you've got 5.3. Well, that's certainly less than 6 minutes. So there's a data point there, and then 0.5. Again, that's between 0 and 6 minutes. So you just fill in the table. So after going through the table and tallying up the results, the frequencies for each bin are given to the right of the tally. And now I'm going to calculate the percent. Now to calculate the percent, it's the same logic as what I used in the spreadsheet. I'm going to take a value. Oh, I don't know. Let's just take the bin 48 to 54. So there were 2 phone calls in that bin, and there were 40 phone calls in total. So 2 divided by 40 times 100%. Well, that's equal to 5%, call it 5.0%. So this would be 5.0%. I'm going to do the same thing for every bin. Well, I'm ready to answer some questions. What percentage of phone calls lasted less than 12 minutes? So those were the phone calls that were grouped into the first 2 bins, 0 to 6 minutes and 6 minutes to 12 minutes. So I add those percentages. So the percentage of phone calls in the bin 0 to 6 minutes is 30%, plus the percentage of phone calls in the 6 to 12 minute bin, which is 25.0%. So that's equal to 55% of the phone calls lasted less than 12 minutes. What percentage of calls lasted a half hour or more, or 30 minutes or more? Well, 30 minutes or more, I'd be looking at that bin, that bin, that bin, that bin. So 30 to 36, 36 to 40, 42 to 46, and 48 to 54. So, so 0 plus 2.5 plus 2.5 plus 10%. So half an hour or more would be 0 plus 2.5 plus 2.5 plus 5, 10.0%. Okay, represent the frequency distribution with histogram and use a percent scale on the vertical axis. Okay, so I'm going to do that manually now. So I have prepared the axes for my histogram for the percentage of phone calls where we want to find out what percent of calls were in what bin, like 0 to 6 minutes, 6 to 12 minutes, etc. And so with the data, well, it turns out 3% of the calls were between 0 and 6 minutes. So what I'm going to do is I am going to draw that here on my histogram. 6 minutes, 30%. I'm going to shade that in. Then turns out that 25% of the calls were between 6 and 12 minutes. I'm going to find 25%. And then I would shape that in. And I'm going to do the same for all of the other percentages for each of the bins. And so here's my histogram, not based on a frequency distribution. Just to be clear, this is based on percentage. It's I think important to distinguish between that. You need to be careful to understand what question you're being asked. Normally, you're going to look at a frequency distribution for a histogram. Well, now the scale on this isn't very good because you can see from the information that nothing really is above 30%. So I could have actually gone from 0 to 100 on the vertical axis. Sorry, instead of 0 to 100, I could have gone 0 to 50 on the vertical axis and expanded my histogram to get maybe a bit clearer information. I'm going to do that now. Clearer information. I'm going to do that now. So I have created a second histogram based on percentage where you can see I've expanded the vertical axis by having my percentages go from 0 to 50 rather than 0 to 100. This, I believe, gives more information as to both the shape of the histogram and the ability to get information out of it.